Here's another installment of our identity proofs. And so I've got 6 more problems we're going to go over here, and let's get into it. So if you haven't tried them yet, I would encourage you to pause, write them down, and give them a shot, and then hit play once you've given them a shot. Now, once again, remember, these are going to take some time, so if you don't get them your first shot, that's okay. All right. Ooh, that's not what I wanted. Let's zoom in on here on 17. And so we need to somehow get it so that tangent squared theta minus sine squared theta is equal to tangent squared theta times sine squared theta. So they, from the previous problems that we've been doing, they're getting a lot more challenging here. This one you could work with either side, and so I could do either one. What I'm going to do is I'm going to work with the right side and see if I can get to the left. So I'm going to start over here and try to eventually end up over there. And the reason I'm going to do that is I know that sine squared is, let me grab a pen here. There we go. We'll grab that one. But sine squared is 1 minus cosine squared. So I can replace that sine squared right there. So let's do that. We'll write tangent squared theta times 1 minus cosine squared theta. And once again, this isn't the only correct way to do this, so if you did it a different way, that's totally fine. So then, my next step is I'm going to, let's grab a different color, I'm going to distribute that tangent squared into both of those. And when I do that, tangent squared times 1 is tangent squared theta, and tangent squared theta times cosine squared theta is tangent squared theta cosine squared theta. Okay, so we're pretty close. If you notice here, we've got tangent squared minus sine squared, and here we have tangent squared minus something. So we just need to turn that something into sine squared. So what I'm going to do is I'm going to use this trig identity over here on the right, that tangent theta is sine theta over cosine theta. And so I'm just going to rewrite this problem, tangent squared theta minus, and then tangent squared theta here is going to be sine squared theta over cosine squared theta times cosine squared theta. And then what I notice is the cosine squareds cancel out, and what I'm left with is tangent squared theta minus sine squared theta. And that's what I'm looking for. Tan squared theta minus sine squared theta. Cool. So we started out with the right side and we ended up with the left side. If you did it the other way, you probably did many of the steps in reverse. All right, let's look at number 18. Here I've got a bunch of stuff on the left. Cosine cubed x plus cosine x sine squared x equals cosine x. So all of this stuff will eventually just simplify down to cosine x. Let's see if we can make that happen. One thing I notice when I look at this, I see it cubed and squared. So I could be using some of these Pythagorean identities down at the bottom on the right. But one thing that kind of sticks out at this for me is I see a cosine x plus a cosine x times sine x. And so I see that I could factor out a cosine x out of both of these terms here. So when I do that, I get cosine squared x plus, so let me just kind of talk how I got this. I'm basically undistributing the cosine x. And so this cosine cubed x turns into squared because I took a cosine out. And then when I factor out a cosine x, all that's left is sine squared x. And then, conveniently enough, Look at that. We've got sine squared theta plus cosine squared theta equals 1. So that means this is cosine x times 1, which is cosine x. Look at that. That looked pretty daunting, but it was just a 3-step proof. Not too bad. So the trick on this one was factor out a cosine out of both terms, and then what was left over was just 1. It was cosine squared plus sine squared. Okay, let's head over to 19. All right, so this one we've got cotangent squared a over 1 plus cosecant a plus 1. And all of that should eventually get us down to cosecant a. All right, there's a couple different ways that I have solved this problem. I'll show you the quicker way, but this is not the only correct way. I'll tell you, the first time I did this problem, I changed this 1, so I'll show you the first step, but then I'm not going to finish it. You can finish this one out on your own if you want a challenge. 1 plus cosecant a to 1 plus cosecant a over 1 plus cosecant a. So what I did was I got a common denominator, and I changed that 1 into 1 plus cosecant a on top and bottom. And then I combined like terms, I took the top and I got it to just one trig identity. So I changed cotangent squared into that, and then I solved it from there. What I'm going to do instead of getting a common denominator here, is let's erase this. And by the way, where I was starting with that one was actually a really good way to do it. It's just going to take maybe an extra step. So I'm going to change this cotangent squared a into cosecant squared a minus 1. And so the trick here, the thing that you have to understand, is this top thing is factorable. That you can factor into cosecant a plus 1 and cosecant a minus 1. All of that over 1 plus cosecant a plus 1. So whenever you hit, this is called difference of two squares. I'll write that out. Difference, let's see, where's my erase button? There we go. Difference of two squares. Whenever you have the difference of two squares, you can factor that the way I did. So then what I notice is I've got a cosecant a plus 1 and a 1 plus cosecant a. Those are the same thing. So I can cancel those out. And now what I'm left with is cosecant a minus 1 plus 1. And that just turns into cosecant a, which is what we're looking for. All right. So number 19 is in the books. Number 20, I've got secant squared theta minus 1 times cosecant squared theta minus 1. And that should just give me 1. Pretty crazy. When I multiply those things out, I just get 1. All right, so I think I see some stuff over here on the right. I have the 1 already circled in pinkish purplish over there. Cosecant squared theta minus 1 is cotangent squared, so I can replace that. And then secant squared theta minus 1, is tangent squared. So I'm going to use, I did it again. I'm going to use those two. So I'm going to replace secant squared theta minus 1 with tangent squared theta. Then I'm going to replace cosecant squared theta minus 1 with cotangent squared theta. And if you know that these two are reciprocals, which we can say right there, that cotangent is 1 over tangent. So this would be tangent squared theta times 1 over tangent squared theta. And those would cancel out, and you'd be left with 1 equals 1. All right, let's look at number 21. We've got sine x over cosecant x plus cosine x over secant x, and that equals 1. All right, so I don't see anything squared here, so that tells me that I cannot be using the stuff on the bottom of my toolbox over on the right. So what I'm going to be doing is I'm going to be using that one and that one. But secant is 1 over cosine, and cosecant is 1 over sine. So this will be sine x over, and then cosecant is 1 over sine x plus cosine x over secant is 1 over cosine x. And then when we're dividing by fractions, we can multiply by the reciprocal. So this becomes sine x times sine x over 1 plus cosine x times cosine x over 1. So all I did was I multiplied by the reciprocal of the bottom. And that's where those two fractions came from. So then we've got sine x times sine x is sine squared x. And we have cosine x times cosine x is cosine squared x. And that one is right on the bottom. So that is 1. All right, and then the last one, number 22. We have cosine to the 4th minus sine to the 4th equals 1 minus 2 sine squared theta. All right, well, this one is, we have not dealt with any to the 4ths yet, and so this is definitely a bit more challenging. But if you notice, this is the difference of 2 squares. It also happens to be the difference of 2/4, but we can factor that thing on the left. And that's what I'm going to do to start, is I'm going to factor that thing. And when you, so just a reminder, I'll kind of write this at the bottom. If you have a squared minus b squared, this becomes a plus b and a minus b when we factor that. And so we're going to be doing the same thing up there. So here we're going to have cosine squared theta plus sine squared theta, and then cosine squared theta minus sine squared theta. So in this case, our A is cosine squared and our B is sine squared. So when you square those, you get to the 4th. So I factored the original, and I got those two things. So it looks like I made it a lot more messy, but really, this actually helps a lot, because if you notice, this thing right here is just 1. So now we're left with 1 times cosine squared theta minus sine squared theta. And somehow I need to get it to be 1 minus 2 sine squared theta. Okay, well, so that tells me I do not want to, let's grab something a little brighter. I don't really want to mess with that, because I want a sine squared theta in there, but I do want to get rid of that. So what I can do is say that cosine squared theta is 1 minus sine squared theta. So I'm going to replace cosine squared with 1 minus sine squared theta, and then I'm going to leave the other one alone, minus sine squared theta. And then I can combine these like terms, and I've got 1 minus 2 sine squared theta. And that's exactly what we're looking for, sine squared theta. All right. So those are those 6 problems. Hopefully that helps us out a little bit.